Kenya's geothermal edge in direct air capture. Octavia Carbon, a climate tech startup based in Kenya, is using the country's geothermal resources to build what may become one of the most scalable direct air capture DAC platforms in the global south. The company, founded in 2022, has developed a modular DAC system that draws on Kenya's consistent and low-carbon geothermal electricity, a critical advantage in reducing both the operational cost and emissions footprint of carbon removal. DAC is notoriously energy-intensive, and achieving net negative emissions requires a clean energy input. Kenya's geothermal grid, which supplies over 90% of the country's renewable electricity, provides both the reliability and low-carbon intensity that DAC needs to scale. Beyond electricity, geothermal plants also produce waste heat, an energy stream that Octavia has integrated into its process to further reduce energy costs. Combined with the volcanic geology of the Rift Valley, ideal for permanent CO2 storage, this setup supports both the technical and economic case for DAC in the region. Octavia is planning to scale its platform through a modular architecture. Its first commercial project, dubbed Project Hummingbird, is targeting 1,000 tons of CO2 removal annually by 2026, with longer-term ambitions to reach over 1 million tons per year by 2030. At a time when Africa is shifting from being seen as climate vulnerable to climate innovative, Octavia is positioning itself within a broader push for green industrialization on the continent. Precision sensors at the core of carbon removal integrity. Reliable CO2 measurement is central to Octavia's process and to the trust behind its carbon removal claims. DAC systems must accurately track carbon at every stage, from low ambient air concentrations to nearly pure CO2 during capture, compression, and injection. Any errors in measurement can undercut both process efficiency and verification of actual carbon removal. Early on, Octavia's engineers identified that many commercially available CO2 sensors couldn't maintain accuracy across the wide range of concentrations in their process. Variability in sensor performance, especially under fast cycling conditions, led to measurement drift, impacting system optimization and energy efficiency. Rapid capture cycles, shifting from ambient levels, OCLI 430 ppm, to highly concentrated streams, exposed sensors to stress that many couldn't withstand without frequent recalibration. After a series of tests, the company selected Vaisala's CarboCap-based sensors, specifically the GMP 343 and MGP 241 models. These sensors stood out for their ability to maintain accuracy both below 400 ppm and up to high-purity CO2 levels. Designed with silicon-based NDIR optics and self-compensating filters, the probes provided long-term stability under harsh operating conditions and high-frequency cycling. This sensing capability has become a foundational part of Octavia's quality control and optimization strategy. It enables accurate saturation detection in sorbent materials, critical for timing the adsorption-desorption process, and ensures consistent data for third-party verification of carbon credits. As Octavia expands, reliable CO2 tracking helps support investor confidence and customer assurance in the durability of the removals being offered.